Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about solving exponential equations with logarithms.
Minute Math, when you need help you use Minute Math.
We're given this problem right here. 3 to the power of b is equal to 17, and we need to solve this equation. Well, one thing we know about logarithms is we can take the log of both sides there. So if I take the log of 3 to the b is equal to the log of 17. When we do that, this exponent right here, that b, can come out front. So we're left with b times the log of 3 is equal to the log of 17. From there, to get b by itself, we divide both sides by the log of 3. As such, the 3's cancel. And we're left with b here is equal to, and it's going to be approximate because we're going to round this. When you use our calculator, log of 17 divided by log of 3 comes out to be a 2.5789 rounded. And so our final answer is b is approximately 2.5789. We're given this problem right here. 12 to the power of r is equal to 13, and we need to solve this. One thing we know is when we can take a natural log of both sides of an equation here, if I take the natural log of 12 to the power of r, and it's going to be equal to the natural log of 13 here. When that happens, this exponent of r can come out front. So we have r times natural log of 12 is equal to natural log of 13. Continuing on this track, we have multiplication here. Divide both sides by natural log of 12 to eliminate there on the left. But we bring it to the right-hand side. R is now by itself, and this is going to be approximately, because we're going to round this answer here. And using our calculator, the natural log of 13 divided by the natural log of 12 comes out to be 1.0322. And that is our final answer. We're given this problem right here. 9 to the power of n is equal to 49, and we need to solve this. Well, if I take the natural log of both sides, certain rules apply here. This allows us to take this exponent of n and put it in front there with multiplication. So we have n times the natural log of 9 now is equal to the natural log of 49. Opposite of multiplication is division. Divide both sides by the natural log of 9. And this helps us get n by itself, which is our goal. N is equal to, now using our calculator, we're going to approximate this. Okay, that's an approximation equal sign there. And the natural log of 49 divided by the natural log of 9 comes out to be 1.7712. And so our final answer here is n is approximately equal to 1.7712. We're given this problem right here. 16 to the power of v is equal to 67, and we need to solve this equation. One thing we know about logarithms is that if I take the natural log of both sides, which I'm allowed to do, but it's not a 7, it's a v, and take natural log of 16 to the power of v is equal to natural log of 67 here. When I do that, this exponent of a power of v can come out front. So we're left now with v times natural log of 16 equals natural log of 67. Then from there we divide both sides by natural log of 16. This cancels, and v is now by itself. It's going to be approximately, because we're going to use our calculator here, and we're going to round. And the natural log of 67 divided by the natural log of 16 comes out to be a 1.5165. Again, that's approximate. And so our final answer here is v is approximately equal to 1.5165. I'm given this problem right here. 3 to the power of a is equal to 69, and we need to solve this equation. We know that I can take the natural log of both sides of an equation here. So if we do that, natural log of 3 to the power of a is equal to natural log of 69. This allows us now to take this exponent of a and bring it out front. That gives us an a times natural log of 3, which is equal to natural log of 69. From there, divide both sides by natural log of 3. natural log of 3 cancels on the left-hand side, giving us a by itself. Now this is going to be approximate here, but when we use our calculator, natural log of 69 divided by natural log of 3, and we round it, we get approximately a 3.8540. And so our final answer here is a is approximately equal to 3.8540. We're given this problem right here. 6 to the power of r is equal to 51, and we need to solve this equation. Well, we know that we can take the natural log of both sides here. So let's do that. Natural log of 6 to the power of r is equal to natural log of 51. When we do that, this exponent of r can come out front. So we have r times natural log of 6 now is equal to natural log of 51. From there, we can divide both sides by natural log of 6. This cancels on the left, leaving us r by itself. This answer is going to be approximate now. We use our calculator, and natural log of 51 divided by natural log of 6 comes out to be a approximate 2.1944, and that's going to be rounded. And so our final answer here is r is approximately equal to 2.1944. We're given this problem right here. 6 to the power of n equals 99, and we need to solve this equation. We can take the natural log of both sides of the equation here. Natural log of 6 to the power of n is equal to natural log of 99. That allows us to bring down this exponent. Our rules state that this exponent can come out front now. So n times natural log of 6 is equal to natural log of 99. From there, we can divide both sides by natural log of 6. The natural log of 6 will cancel on the left, leaving us with n by itself. This is going to be an approximate answer, but using our calculator, natural log of 99 divided by natural log of 6 comes out to be approximately 2.5646 when we round it. And so our final answer here is n is approximately equal to 2.5646. We're given this problem right here. 20 to the power of r is equal to 56, and we need to solve this equation. Our rules with logarithms state that we can take the natural log of both sides. So we take the natural log of 20r and the natural log of 56. When that happens, this exponent of r can come out front. So we have r times natural log of 20 is equal to natural log of 56. From there, we divide both sides by natural log of 20. Natural log of 20 cancels on the left-hand side, leaving us with r by itself. That's going to be approximately equal to natural log of 56 divided by natural log of 20 comes out to be, when we round it, 1.3437. And so our final rounded approximate answer is r is approximately equal to 1.3437. We're given this problem right here. 5 times 18 to the 6x power is equal to 26, and we need to solve this. Well, first I'm going to try to get this 18 to the 6x by itself. So I'm going to divide both sides by 5. I'm left with that 18 to the 6x power, and that's going to be equal to 26 divided by 5 comes out to be a 5.2. Then from here, I can take the natural log of both sides of the equation. So to do that, I take the natural log of 18 to the 6x power, the natural log of 5.2. What that allows me to do is take this exponent of 6x and bring it out front. So we're left now with the 6x times natural log of 18 is equal to natural log of 5.2. Well, try to get x by itself. We divide both sides by a 6 times natural log of 18, like so. We can do that for both as well, multiplication, right? 6's cancel, natural log of 18 will cancel, and x is now by itself. This is going to be approximate, and we're going to use our calculator, but natural log of 5.2 divided by 6 times natural log of 18 comes out to be the approximate answer of 0.0951. And so our final answer here is x is approximately equal to 0.0951. We're given this problem right here. e to the x minus 1 power minus 5 is equal to 5, and we have to solve this equation. Well, first thing, I'm going to add a 5 to both sides. Let's try to get e to the x minus 1 by itself. So I add a 5, pretty simple, to both sides here. And I'm left with an e to the x minus 1, and that's going to be equal to 5 plus 5, which is 10. You should get that. But then from here, our rules of logarithms tell us that we can take a natural log of both sides. So I'm going to take the natural log of both sides, natural log of e to the x minus 1 and natural log of 10. That allows me to take this exponent right here and bring it out front. So we have now an x minus 1 times natural log of e is equal to natural log of, well, 10. Well, what's the natural log of e? Well, natural log of e is just 1. 1 times anything is itself. So really, don't need to write that. And we just have an x minus 1 here is equal to natural log of 10. I add a 1 to both sides. And I'm left with x equals, well, natural log of 10 plus 1. Let's use our calculator here, mainly because of natural log of 10. And that comes out to be approximately, because we're going to round it, a 3.3026. So again, natural log of 10 plus 1 is 3.3026 rounded. And so our final answer here, again, is x is approximately equal to 3.3026. We're given this problem right here. 9 to the n plus 10 power plus 3 is equal to 81, and we have to solve this equation. Well, first thing I want to do is subtract a 3 to both sides. Let's get this 9 by itself, or 9 to the power. In doing so, I have 9 to the n plus 1, or 10 power, is equal to, and 81 minus 3 is a 78. Now we're allowed to take the natural log of both sides of the equal sign here. In doing so, that causes this exponent that we can bring it out front with multiplication. So we have an n plus 10 now is multiplied by natural log of 9, and it's equal to natural log of 78. I can divide both sides by natural log of 9, as so. And I'm actually going to leave that on the right-hand side there, like that. So we have an n plus 10 here equals natural log of 78 over natural log of 9. If we subtract a 10 to both sides here, I'll write it like that. Okay, this cancels, and n now is going to be approximately, we'll use our calculator, but natural log of 78 over natural log of 9 minus a 10 comes out to be a negative 8.0172. And that is, rounded, our final answer. We're given this problem right here, 11 to the n minus 8 power minus 5 equals 54, and we have to solve this equation. Well, first thing I like to do is add a 5 to both sides here. Let's try to get this n with this power by itself. 5's cancel on the left, and we have 11 to the n minus 8. And that's equal to 54 plus 5 is, well, 59. Our rules of logarithms state that we can take the natural log of both sides here. So let's do that. We take the natural log of both sides of the 11 to the n minus 8 power and the 59. That allows me to take this n minus 8 power and put it out front. We have an n minus 8 here now multiplied by natural log of 11 is equal to natural log of 59. From there we keep solving. I divide both sides by natural log of 11. And that cancels here, and I'm left with a n minus 8 here is equal to natural log of 59 over natural log of 11. Well, now I just have to add an 8 to both sides. I added 8 here. These 8's will cancel. N now is going to be approximately, we'll use our calculator at this point to get a decimal answer when we round it. The natural log of 59 divided by natural log of 11 plus the 8 is approximately a 9.7005. And so our final answer here is n is approximately equal to 9.7005. We're given this problem right here, 16 to the n minus 7 power plus 5 is equal to 24, and we need to solve this equation. Well, first thing I'd like to do is subtract a 5 to both sides. Let's combine that over there. The 5's cancel on left, and we have a 16 to the n minus 7 power is equal to, well, 24 minus 5 comes out to be a 19. Now we're allowed to take the natural log of both sides of the equation here. So take the natural log of both sides. And what does that do? That allows us also now to take the n minus 7 and the exponent and put it out front with multiplication. We have an n minus 7 here with multiplication times the natural log of 16 is equal now to natural log of 19. Keep on going. This is multiplication, so we can divide both sides by natural log of 16. That cancels, and we're left with an n minus 7 here is equal to, I'm going to leave it as such, natural log of 19 over natural log of 16. From there, I have to add a 7 to both sides. The 7's cancel. N is now by itself. We're going to use our calculator to approximate this value. A natural log of 19 divided by a natural log of 16 plus a 7 comes out to be rounded 8.0620. And so my final answer here is n is approximately equal to 8.0620. We're given this problem right here, 20 to the negative 6n plus 6 is equal to 55, and we need to solve this equation. Well, first thing I want to do is subtract a 6 to both sides of the equation here. That cancels this 6 out, and we're left with a 20 to the negative 6n power on the left. That's equal to 55 minus 6, which is a 49. But then from here, we're allowed to take the natural log of both sides of the equation. When we do that, our exponent here can come out front with multiplication. So we have a negative 6n times natural log of 20 is equal to natural log of 49. I divide both sides by natural log of 20 here, and that cancels right there. I have a negative 6n now on the left, and on the right I have a natural log of 49 over natural log of 20. I can multiply both sides by negative 1 over 6. And this is going to cancel the negative 6 on the left. And now is going to be an approximate answer, and we'll use our calculator here. Natural log of 49 over natural log of 20 times a negative 1/6, make sure I got my spot here, times a negative 1/6 here, gives us an approximate answer of a negative 0.2165. And so our final answer here is and is approximately equal to a negative 0.2165. We're given this problem right here, 5 times 6 to the 3m power, and that's equal to 20. And we got to solve this. Well, let's try to get 6 to the 3m power by itself first. So I'm going to divide both sides by 5. 5's cancel on the left, giving us 6 to the 3m power. But that's equal to 20 divided by 5, which is 4. Now, our rules of logarithms state that we can take the log of both sides. So we take the natural log of both sides, make it easier. And we have natural log of 6 to the 3m is equal to natural log of 4. With that being said, our exponent, 3m, the power, can come out front with multiplication. So we have 3m now times natural log of 6 is equal to natural log of 4. From there, divide both sides by natural log of 6. Natural log of 6 cancels, and we're left with 3m is equal to natural log of 4 over natural log of 6. I then can get rid of this 3 by multiplying both sides by 1/3. The 3 and 1/3 cancel on the left, and m is now by itself. This is going to be approximate because we're going to use our calculator here. A natural log of 4 divided by a natural log of 6 times a 1/3 is an approximate answer of 0.2579. And so our final answer here is m is approximately equal to 0.2579. We're given this problem right here, 8 to the negative 5a power minus 5 is equal to 53, and we need to solve this equation. Well, first thing I want to do is add a 5 to both sides. This cancels the 5 on the left, giving me 8 to the negative 5a power left over. On the right, 53 plus 5 is a 58. Okay. Well, we can take the natural log of both sides here of the equation, and what that does, it allows us to take this exponent of a negative 5a and bring it out front. So we have a negative 5a here times natural log of 8 is equal to natural log of 58. From there, we can divide both sides by a natural log of 8, And actually, while I'm at it, let's divide both sides by a -5 as well. Look what cancels. Natural log of 8 cancels here, -5 cancels here, and we have a by itself. That's going to be approximately equal to, and this is where we'll use our calculator, the natural log of 58 divided by -5 times natural log of 8 comes out to be approximately a -0.3905. And so our final answer here is A is approximately equal to -0.3905. We're given this problem right here. 3.4 times e to the 2 minus 2n minus 9 is equal to -4. We have to solve this logarithm. Or sorry, this equation by using logarithms. Well, first thing I like to do is I'm going to add a 9 to both sides. We have a 3.4 e to the 2 minus 2n, and -4 plus 9 is, well, a good old 5. From there, I'm going to divide both sides by a 3.4. 3.4 is cancel on the left, and we have e to the 2 minus 2n, and that's going to be equal to, and I'm going to leave it actually like this, 5 over 3.4. I like to do all my calculations at the end. Now, our rules with logarithms is we can take the natural log of both sides of the equation here. What does that do? That allows us to take this exponent and bring it out front. We have a 2 minus 2n now times the natural log of e, which goes right here, which is, well, natural log of e is 1. And that's equal to natural log of 5 over 3.4. So with all that being said, we're just solving for n here. So our steps here, I'm going to subtract a 2 to both sides, as such. Kind of like that, whatever. The 2 cancels here, and we have a -2n left over, is equal to natural log of 5 over 3.4 minus 2. From there, divide both sides by a -2. The -2's cancel here. And what does that give us? I'll write it up here. N is approximately, and this is where I do the calculations with my calculator, natural log of 5 divided by 3.4 minus 2 all over a -2. And that comes out to be approximately a 0.8072. That's a 0 right here. And so our final answer here is n is approximately equal to 0.8072. We're given this problem right here, -6 times e to the 8n plus 8 minus 3, and that's going to be equal to -23. We have to solve this. So let's try to get this part by itself, that e to the power. So I'm going to first add a 3 to both sides. I have a -6 now is equal to e to the 8n plus 8 power, and that's equal to -23 plus 3, which is a -20. I divide both sides by a -6 here, and that's actually great. -6 cancels. We have e to the 8n plus 8 power, and well, -20 divided by -6, we make that a positive number. Right, 2 negatives make a positive. 20 over 6. Now, you might be able to simplify, and you can, but I like to keep it just as is for right now. I can take the natural log of both sides. With that, that means this exponent can come out front with multiplication. So now I have an 8n plus 8 here, multiplied by natural log of e, which is equal to natural log of 20 over 6. Well, natural log of e is just 1, don't need to worry about that. So now I have an 8n plus 8 equals natural log of 20 over 6. Keep using my rules, I subtract an 8 to both sides, and I have an 8n equals, well, natural log of 20 over 6 minus 8. Divide both sides by 8, and I'll put it up here. And now it's going to be approximately equal to, when we use our calculator, when we take the natural log of 20 over 6 minus 8 all over 8, that comes out to be approximately a -0.8495, and that's rounded. And so our final answer here is n is approximately equal to a -0.8495. We're given this problem right here, a e to the -3.9n minus 1 power minus 1 is equal to a -3, and we have to solve this. Well, first thing, I'm going to add a 1 to both sides. I have a e to the -3.9n minus 1 power is equal to -3 plus 1, -2. Now I divide both sides by a -1. That's going to cancel out this negative over here on the left. We have e to the negative 3.9n minus 1 power, and that's equal to negative 2 divided by negative 1, which is a positive 2. From here, take the natural log of both sides, and that allows me to take this exponent and bring it up front. So our rules tell us that with natural logs and exponents, we have a negative 3.9n minus 1, and that's going to be all multiplied by the natural log of e. Well, what's the natural log of e? Just 1. Don't need to write anything anymore. And that's equal to natural log of 2. From here, I'm just solving for n. I add a 1 to both sides, and I have a negative 3.9n equals natural log of 2 plus 1. I'm going to kind of just leave it out without using a calculator right now. Divide both sides by a negative 3.9. That cancels on the left. Leave me n by itself. It's going to be approximately, and here's where I use my calculator in this last step. The natural log of 2 plus 1 divided by a negative 3.9 comes out to be approximately a negative 0.4341. And our final answer here is n is approximately equal to negative 0.4341. We're given this problem right here, negative 2 times e to the 7v plus 5 minus 10, and that's equal to negative 17. And we have to solve for v. First thing is I'm going to add a 10 to both sides. In doing so, I have a negative 2 e to the 7v plus 5 left over on the left. And negative 7 plus 10, well, is a negative, or negative 17 plus 10 is a negative 7. Divide both sides by a negative 2 now. Negative 2's cancel on the left, leaving with e to the 7v plus 5. And that's equal to, well, negative divided by negative is a positive. So we have 7/2 here. Now we're allowed to take the natural log of both sides of the equation. What that does is take this exponent here and brings it out front with our rules. We now have 7v plus 5 is multiplied by natural log of e. That's equal to natural log of 7 over 2. Well, luckily for us, natural log of e is just equal to 1, right? So that just equals a 1. 1 times anything is itself. So solving this, I subtract a 5 to both sides, and I have a 7v left over. That's it, or over here, that cancels. Is equal to a natural log of 7 over 2 minus 5. Divide both sides by 7, and I'll put it up here. V is by itself, and it's an approximation, and this is where I use my calculator. Natural log of 7/2 minus 5 divided by 7 comes out to be a good old negative 0.5353. And so our final answer here is v is approximately equal to negative 0.5353. I'm given this problem right here. Negative 3 e to the 7a plus 9 power plus 6 is equal to a negative 6, and we have to solve this equation. Well, first thing, I'm going to subtract a 6 to both sides. That cancels out here on the left, and I have a negative 3 e to the 7a plus 9 power, and that's equal to negative 6 minus 6, negative 12. Divide both sides by a negative 3 here, because there's multiplication going on there. That cancels out the negative 3, and on the left I'm left with e to the 7a plus 9 power is equal to, well, negative 12 divided by negative 3. The negatives cancel, so it becomes a positive, and 12 divided by 3 is 4. From here, I can take the natural log of both sides. That allows me to take this exponent and bring it out front. So 7a now plus 9 is going to be multiplied by, well, natural log of e. Natural log of e is just 1. Don't need to write that. And that's equal to natural log of 4. Solving for a, I subtract a 9 to both sides. And 7a is equal to natural log of 4 minus 9. Divide both sides by 7. And the a is by itself. I'll put it up here. It's going to be approximate, and we'll use our calculator now. Natural log of 4 minus 9 divided by 7 comes out to be approximately a negative 1.0877. And so our final answer here is a is approximately equal to a negative 1.0877. I'm given this problem right here. Negative 3 e to the 9x minus 1 power plus 6 equals a negative 58. I have to solve this equation. I'm first going to subtract a 6 to both sides here. In doing so, I have a negative 3e to the 9x minus 1 power. The 6's cancel. That's equal to negative 58 minus a 6, which comes out to be a negative 64. I now divide both sides by a negative 3. Negative 3's cancel on the left, and we have e to the 9x minus 1 power is equal to, well, the negatives cancel, and we just have a positive 64 over 3. I don't worry too much about simplifying this right now. From here, I know I can take the natural log of both sides of the equation. But what it does here with this natural log of e to the exponent of 9x minus 1, I can take that exponent and put it out front. That gives us a 9x minus 1 here multiplied by natural log of e. And that's equal to natural log of 64 over 3. Well, natural log of e is just 1. Don't really worry about that. And 1 times anything, get rid of it. So now I just add a 1 to both sides here. So I have a 9x is equal to natural log of 64 over 3 plus 1. Divide both sides by 9. And x is all by itself. We use our calculator here. It'll be approximate. The natural log of 64 over 3 plus 1, all divided by 9, comes out to be a 0.4511 when rounded. And so our final answer here is x is approximately equal to 0.4511. I'm given this problem right here, a negative e to the 6 minus 9p plus 5, and that's equal to a negative 48.4, and we need to solve this equation. I'm going to subtract a 5 to both sides first. This gives me a negative e to the 6 minus 9p power, and that's equal to, well, negative 48.4 minus 5 is a negative 53.4. Now, I don't like that negative there, so I'm going to put a positive on both sides, right? Divide both sides by negative 1, positive, positive, good. Now our rules state that we can take the natural log also of both sides of the equation. So natural log here, what that does, it allows me to take this exponent and bring it out front. We have a 6 minus 9p here, multiplied by natural log of e, which is equal to natural log of 53.4. What's the natural log of e? That's 1. Natural log of e is 1. That's what's great about this. And so we have this 6 minus 9p here. That's equal to natural log of 53.4. So let's solve for p. Subtract a 6 to both sides. We have a negative 9p equals natural log of 53.4 minus a 6. Divide both sides by negative 9. Negative 9's cancel, and I put the p up here. And p is approximately equal to natural log of 53.4 minus 6 divided by negative 9. And when using our calculator, that comes out to be a 0.2247. And so our final answer here is p is approximately equal to 0.2247. I'm given this problem right here. Negative 10 times e to the 2 minus 2b power minus 6 is equal to negative 66, and we have to solve this equation. First step, I'm going to add a 6 to both sides. Negative 10 here is equal, or times e to the 2 minus 2b is equal to negative 66 plus 6, which is a negative 60. I now can divide both sides by a negative 10. Negative 10's cancel here on the left, and so we have e to the 2 minus 2b here is equal to, and negative 60 divided by negative 10 is a positive 6. From here, I'm allowed to take the natural log of both sides of the equation. That's beneficial because this exponent of 2 minus 2b can come out front. So now we have 2 minus 2b being multiplied by natural log of e is equal to natural log of 6. Well, what's the natural log of e? That's just 1. Don't need to write that. So it's just a 1 here. So we have now 2 minus 2b is equal to natural log of 6. Solve for b. Subtract the 2 to both sides. And I have a negative 2b is equal to natural log of 6 minus 2. I'll rewrite that up here. Negative 2b is equal to natural log of 6 minus 2. I now divide both sides by a negative 2. And I'm left with b by itself right here. Now it's going to be approximate, and we're going to use our calculator. A natural log of 6 minus 2 divided by a negative 2 comes out to be approximately 0.1041. And so our final answer here is b is approximately equal to 0.1041. I'm given this problem right here. 6e to the negative 4k minus 10 minus 4 is equal to 63, and I got to solve this equation. First thing, I'm adding a 4 to both sides. With that, I'm left with a 6e to the negative 4k minus 10 power is equal to 63 plus 4 and 67. And now I also have to divide both sides by 6. Let's get that e part by itself. 6's cancel. And we have e to the negative 4k minus 10 here is equal to 67 over 6. Well, then from here, I can take the natural log of both sides. By doing that, this exponent can come out front with multiplication. So we have a negative 4k minus 10 is being multiplied by a natural log of e, which is equal to natural log of 67 over 6. Oof, a lot of work here. Well, natural log of e is equal to just 1. So 1 times, well, this part is just that part, right? The negative 4k minus 10 is by itself. It's equal to natural log of 67 over 6. I'm going to add a 10 to both sides, and with that I'll show that work up here. We have a negative 4k left over on the left, and it's equal to natural log of 67 over 6 plus 10. I divide both sides by a negative 4, and we're left with k now by itself. And that's going to be approximate, and we're going to use our calculator here. The natural log of 67 over 6 plus 10 divided by a negative 4 comes out to be approximately a negative 3.1032. And so our final answer here is k is approximately equal to negative 3.1032. I'm given this problem right here. 6 times e to the 5x minus 6 power minus 4 is equal to 50, and we have to solve this. First thing is, I'm going to add a 4 to both sides. With that, the 4's cancel on the left here, and I have a 6e to the 5x minus 6 power, and it's equal to 50 plus 4, which is 54. I then am going to divide both sides by, well, 6 here. 6's cancel right there, and I'm left with e to the 5x minus 6 power, and 54 divided by 6 is 9. From there, I want to get this 5x minus 6 kind of down from the power. If I take the natural log of both sides of the equation, I then can take this exponent and put it out front. We now have 5x minus 6 here times the natural log of e, which is equal to natural log of 9. Well, natural log of e is just equal to, well, 1. So I can rewrite this all up here as a 5x minus 6 is equal to natural log of 9. And we're solving for x here. Add a 6 to both sides. 5x equals natural log of 9 plus 6. Divide both sides by 5, and x is now by itself. X is equal to, and this is actually approximate here, we're going to use our calculator here. Natural log of 9 plus 6 divided by 5 comes out to be approximately a 1.6394. And so our final answer here is x is approximately equal to 1.6394. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.